Testing, testing. Hello. Surprise, I'm back. I feel like I've become, what's something that doesn't show up often? I don't know. So mostly each time I am away and then I come back, I'm like, I don't really know what to say in the intro, so. Oh, hi. Hello. Good time of day. Whether it's morning or any other time, because the earth moves and time is, relative, but not that way. I don't know. Oh, I don't know. Who are you? What is happening? My ear is being cut off, but it's fine. Okay. Yeah, we made it. I'm a bit pixely, but hey, life happens. Yeah, life is cool. It's fine. It's doing great. She's trying her best. All right. I think I should get on with the learning because I have not done that in the past few days. Which, technically I'm still screen nice. Okay. Technically I'm still trying to learn stuff on my own, but I do enjoy learning with quote unquote you. Okay. Give myself a reminder. Last time, I do want to be here. I do want to start from this part. Last time we did the byte pair encoding, and as far as I remember, we are. Oh, I actually remember. Okay. We made a vocab of Okay. We made a vocab of letters first, and then we checked pairs of letters, and then we checked pairs of pairs, and then the pairs became apples. Bad joke, but was there any visualization? Not here, but there was a really cool animation in this video. You can go back and watch it. I'm gonna start the word piece tokenization, which, who uses it? Someone, because byte pair I think is being used by GPT. Yes, it's being used by GPT-2 and Roberta and Bart for word piece. I'm surprised that the order is like byte pair, word piece, and then unigram. Like, I feel like unigram would be easier, but hey. Okay, so let's start with word piece. Let's see what's different. So word piece is the tokenization algorithm Google developed to pre-train BERT. It has since been reused in quite a few transformer models based on BERT, such as Distill BERT, Mobile BERT, Funnel, Transformer, and MPNet. Very similar to BPE in terms of training, but the actual tokenization is done differently. All right. I really liked BPE. The idea was like nice. So playing this video, it starts with a really loud whoosh. I don't know how louder it is from my voice. So here you would go. Yeah, okay.
Let's see together what is the training strategy of the word pieces algorithm and how it performs the tokenization of the text once trained. Word pieces is a tokenization algorithm introduced by Google. It is used, for example, by BERT. To our knowledge, the code of word pieces has not been open source.
Oh.
So we base our explanations on our own interpretation of the published literature. So what is the training strategy of word pieces? Similarly to the BP algorithm, Word pieces starts by establishing an initial vocabulary composed of elementary units, and then increases this vocabulary to the desired size.
So this is just a frequency list, I guess.
To build the initial vocabulary, we divide each word in the training corpus into the sequence of letters that make it up. As you can see, there is a small subtlety. We had two hashtags in front of the letters that do not start a word. By keeping only one occurrence per elementary unit, we now have our initial vocabulary.
That's smart. So we now know what is a continuation of a word and what is at the beginning. I guess we don't know what's at the end, but I don't think that matters as much. So up until now, this is the same as byte pair. Does that mean byte pair learned from this? Let's see.
We will list all the existing pairs in our corpus. Once we have this list, we will calculate a score for each of these pairs. As for the BP algorithm, we will select the pair with the highest score. Taking, for example, the first pair composed of the letters H and U. The score.
Yes, we also take into account the repetition in the corpus. And yeah, I guess wanted to say that BPE also cared about word limit. No, wait, word boundary, but not visually.
Score of a pair is simply equal to the frequency of appearance of the pair divided by the product of the frequency of appearance of the first token by the frequency of appearance of the second token. Thus, at a fixed frequency of appearance of the pair, if the subparts of the pair are very frequent in the corpus, then the score will be decreased. In our example, the pair U appears 4 times, the letter H 4 times, and the letter U 4 times. This gives us a score of 0.25. Now that we know how to calculate this score, we can do it for all pairs. We can now add to the vocabulary the pair with the highest score, after merging it, of course. And now,
so we have a equation for the score. I don't think we had it in the byte pair encoding. It was just frequency. Let's see if that matters.
We can apply the same fusion to our split corpus. As you can imagine, we just have to repeat the same operations until we have the vocabulary of the desired size. Let's look at a few more steps to see the evolution of our vocabulary, and also at the evolution of the length of the splits.
I guess we also have to have how big do we want our vocab size to be?
And now that we are happy with our vocabulary, you are probably wondering how to use it to tokenize the text. Let's say we want to tokenize the word HuggingFace. Word pieces follow these rules.
I have a problem with the word HuggingFace. Sometimes I write it like one thing, and then I see them writing it as two things, and then now I see them writing it like one thing. So I think, see, there's a space. Why? In my mind, there shouldn't be a space.
We will look for the longest possible token at the beginning of a word. Then, we start again on the remaining part of our word, and so on until we reach the end. And that's it. HuggingFace is divided into 4 subtokens.
That's surprisingly useless. I mean, I bet it's useful for the model, but like just as a human looking at it, it feels like it didn't capture, but it'd probably be the same with the other, with byte pair, so it's fine.
This video is about to end. I hope it helped you to understand better what is behind the word pieces.
Thank you. I feel like I don't know the difference between BPE and WordPiece now. There's a hashtag, is that it? This part says you don't have to go through this. It's not required, but hey, who are we if not the teacher's pet who does everything that's not necessary? Google never open sourced its implementation of the training algorithm for WordPiece, so what follows is our best guess based on published literature, so it may not be 100% accurate. Cool. Like byte pair encoding, WordPiece starts from a small vocab, including special tokens used by the model and the initial alphabet, since it identifies subword by adding a prefix like the hashtag sign. Each word is initially split by adding that prefix to all the characters inside the word. So for instance, the word word would be split W and then double hashtag O, double hashtag R, and double hashtag D. Thus, the initial alphabet contains all the characters present at the beginning of a word and characters present inside a word preceded by the prefix. Then, again, like BPE, the word piece learns merge rules. I mean, I feel like we are overdoing it with a learning word. It's just a thing you apply. It doesn't learn anything. I was like halfway about to curse. Okay. The main difference is that the way the pair to be merged is selected. Oh, right. Okay. So that's a difference that we're seeing. Instead of selecting the most frequent pair, we choose checking the score. And I honestly did not understand the score, so let me try and understand it. Uh-oh, there's an ad about to start. Okay. I tried snoozing it a few times. I'm gonna snooze it one more time. Right? No? Let's see. Because it doesn't make sense for the ad to start like as I am starting. Okay. So the score is frequency divided by first frequency of the first element and then the second as if it's a bigram. First being me, second being what's coming after. Let's see. That's cool. By dividing the frequency of a pair of the pair. Oh, it's a pair. It's a merge. Okay, sorry. My bad. Okay, now I have reason to think the thing looked odd together. That makes a bit of sense. It does. It really might make sense with the checking of the frequency of first and second and with the pair. But also, like, why did the byte pair encoding sound better? Common letters might appear together just because they're more likely. Yes. Not because they're significant. Yeah. That. I can't think of any. I mean, like TH is everywhere, probably. ING, everywhere. Yes. So now I understand the idea of caring about the frequency of the pair. Also, yeah. I mean, the other one, the score was frequency just added together, I think. So by dividing the frequency of the pair by the product of the frequencies of each of its parts, the algorithm prioritizes the merging of pairs where the individual parts are less frequent in the vocab. That's funny, huh? I mean, it's like caring about pairs that are less frequent because they probably hold more meaning, like you said. That happens in a lot more corpora, right? For instance, it won't necessarily merge UN and able with. What's UN and able? What was that? Where was that from? Even if the pair occurs very frequently in the vocab, because the two pairs UN and what's unable will likely each appear in a lot of other words and have high frequency. In contrast, a pair like echu and hugging, okay, will probably be merged faster, assuming the word hugging appears in the verb enable. Thank you. I don't know why. I was like, where is it? How did I even read it? Unable? Wow. All right. Morning brain does not always work. Less frequent are likely to be less frequent individually. Cool. Let's look at the same vocab. So look at the vocab done with BPE and word pairs. Word piece, sorry. So here's my question. Visually speaking, looking at it as a human, which one of them finds better pairs? Is this supposed to be word piece? Let's see. So the initial vocabulary will be this, which is just the letters put together. If we forget about, no special tokens, okay. Most frequent pair is UG, 20 times. But the individual frequency of U is very high, so its score is not the highest. Okay. Oh yeah, we have an ad. I think, or an ad is upcoming in 40 seconds. I think GPT-2 PP, when they switched away from was determined not to be the best. Yes, GPT-2 was BPE. So now, if we're saying was, meaning they're now using something else. I bet they will mention it if they know what the other GPTs are using. But yeah, the score is not really high. No way. That feels like a regression to me. Is that the right way to use it? Like just going back, regressing? That's funny. I love unigrams. I always will. They're my totsarang. But, for tokenization. But, yeah, they're the first thing that I fell in love with. Surprising. All pairs with a U have the same score. Okay. Why? Because it's everywhere? It is exactly everywhere. Okay. So the best score goes to the pair G and S. The only one without a U. The first merging that's learned is GS. I think I saw it split words into better tokens. Unigrams, I mean, I don't know how we split them, but a normal unigram would just be split by space. Wouldn't that be the case? We'll see. We'll get there. I'll get there, inshallah. If not today, some other day. Note that when we merge, we removed the thing. Yeah, it comes to the beginning, obviously. Okay. First thing that was learned is GS, and it's added back here. At this point, U is in all the possible pairs, so they end up with the same score. Let's take the first one, HU. I don't like the fact that it takes the first one arbitrarily. I mean, technically the score of the other ones shouldn't change, but they do because a new pair enters the game. So, then the next score is shared by these two. This is bigger. So the pair with the biggest score is merged. Now the word hug is learned, isn't it? Hug. Woo. We continue. Next merge. I don't have the energy. Are you kidding me? Okay. So tokenization algorithm. Tokenization differs in word piece and BPE, and that word piece only saves the final vocab, not the merge rules learned. Okay. Starting from the word to tokenize, word piece finds the longest subword that is in the vocab, then splits on it. I mean, we have okay, got it. So we just compare words. You find the longest thing in the vocabulary and you compare it. Thank you. Honestly, I'm fine. And someone was like, you might not be getting enough sleep, but past few days I have been getting enough sleep, honestly. And I think this is just a sleepy voice. Thank you. You're being kind. According to my watch, yeah, not enough sleep, definitely. Less than 6 hours. Which is fine. We'll make up for it. I'm mostly like I'm healthy, physically well. Just worried in the brain, that's all. Life is worrying, what do you expect? We use the vocabulary learned in the example above. Hugs is the longest one, starting from the beginning. Okay, so based on what is learned up here, and we didn't do everything, the word hugs would be split into hug and the S. Yeah, all right. Everything is fine. I don't know if I said that in a way that made you feel worried, but I'm just saying, like, when it comes to work, or when it comes to mostly work, there are things that are not under my control and I worry about them. That's everything. That is like making my brain busy. Otherwise, everything is good. Alhamdulillah. So with BPE, we would have applied the merges learned in order. Oh, really? And tokenized as HUGS. So encoding is different. That's funny. We apply the merges learned in order. Why? Now I like the word piece part more. As another example, let's see how the word bugs would be tokenized. B is the longest subword. So BUGS and then U. So, I mean, again, this is based on this, which is not finished. The only thing that comes out of it is GS. B and U are. I know. Hi, Ed. What's up? Tokenization is a rabbit hole, and we are Alice going down the rabbit hole. Isn't it fun though? I like it. Ooh, hi. Hi, Jesus. Hi, Ed. Welcome. And that's how you tokenize bugs. Whoa, Bugs Bunny. It's been a while. Okay. Why is it called Bugs Bunny? I never checked. When the tokenization gets to a stage where it's not possible to find a subword in the vocabulary, the whole word is tokenized as unknown. So, for instance, mug would be tokenized as unknown. What? Don't we have U and then G? Says chat is disabled. Where? Where is chat disabled? Chat is not disabled. Huh. Last time? I, I don't know. I like chat. All right. As the word, why do you have this word here? Okay. Even. Oh. Wait. Is it because the word mug, we don't have M? Don't we have U and G? We have U and G. But because it's not a part of the word? Does that make sense? Ah. All right. So it was just probably a glitch from YouTube. It's working now? Where was I? So M for this word BU does exist but not M. So it would be unknown. Okay, only one token would be unknown, and I prefer that instead of having mug be an unknown, because we have unknown U and G, right? I couldn't find the last few old lives, then a search of your channel name never shows anything. Yeah, my channel name is not wait. A search on my channel does not show the previous lives? Oh, it's alright. No worries. It's just my channel name doesn't come up, which is alright, but the lives are there. In a what do you call it? In a tab, the live tab. Yeah. I was about to say, I think you're on Discord, so you could probably. Yeah, I know. The the only way to find me when I search for something, which I don't normally do, but I have, is searching for hashcode Google competition, and then like explanation or something, and my video is like being recommended there, which is an old video, and hashcode is long gone, so it was something that helped me start the channel, so I love it. Hugs already, PUG already exists right up here. Don't know about the, oh, GS, we have GS. So it would be PU and then GS. Just like how bugs was. Alright. So implementing WordPiece. WordPiece being a tokenization algorithm? Would we call it algorithm? Let's take a look at an implementation. Yes, we do. Okay, of the WordPiece algorithm, like the BPE. This is just pedagogical, and you won't be able to use it on a big corpus. Okay, just for learning purposes. We will use the same corpus like we did with the BP. All right. Yes. how bad YouTube search engine is. Yeah, the thing I don't like about YouTube search engine is that, I don't know, I was searching something very, like, you know, like academic and dry, and something about a paper or something. And it's like, okay, the first 3 videos are related to that. Oh, thanks. Thanks for the like and subscribe. Appreciate it. And then a few videos later, or like after the 3rd one, it's like, others you might like, and it's like a K-pop song. I'm like, yeah, I know I watch K-pop, but that has literally nothing to do with what I just searched. So like, just the style is also very infuriating. So yeah, like, at least recommend me something that has anything to do with it. We love YouTube. 3 thumbs up. Okay. I only have 2, but I was hoping someone else would do it. Should we run anything, or should we clone the clone? Hello? Hi Ed. Am I streaming right now? You can hear me, I think. I'm gonna fix my face. I understand that. Yeah, okay. My internet just stopped existing for a second. I need a BRB in a second, okay? Yeah. Okay. We're back? Okay, we're back. And this is fine. Oof, great. The thing that is somewhat surprising is YouTube didn't give out. It's on the same link. Normally it gives out. One tiny BRB and I'll be back for real. Why does Twitch say that I'm unstable? How dare you? Okay, so going back through the chat. Yeah, you made a YouTube channel solely for AI stuff because otherwise you'd get anime. Understandable. I mean, I technically have multiple channels, but no, I haven't. I do click on stuff that I don't want recommended, but I'm curious. In a incognito tab, but that's as far as I do. You found the lives. Thank you. Great. We are back. Twitch died, but YouTube didn't. I am really surprised. Twitch is just a refresh. It's fine. But the moving to a new URL is something that I wish that it wouldn't happen. So, yay. See, we have an error, which is there was no internet. And we copy this to our drive. And then we close this. And then we go back. And then we zoom in. And then we start learning stuff, apparently. So, first, we need to pre-tokenize the corpus into words. It's called splitting, right? Since we are replicating a word piece tokenizer like bird, we will use the bird case base cased tokenizer for pre-tokenization. So we just call it, all right? I've been having some inference related issues. Wish me luck. I'll try to fix it today. We compute the frequencies of each word in the corpus. So we haven't tokenized anything yet, but we're making a, oh, it's just, we're writing code. I thought it's a new method. Okay. Word frequencies is a dictionary. And then we say for the text that's in the corpus, tokenize, do the pre-tokenization. Why words with offset? Isn't there something here that we say that has to do with offset? Isn't it like some sort of attribute, or I thought it was. Okay. And then we will have the word and the offset. Oh, this part is the we're not taking offset, are we? Just word, and then the corresponding thing would be frequency. Okay. And this is the output. This comes up 3 times, is 2 times, so on and so forth. And then, I mean, I could run some of the stuff that's here for fun. As we saw before, alphabet is the unique set composed of all the first letters of the words. Really? I didn't know that. And all the other letters that appear in the word prefixed by the hashtag thing. So searching for each word in the word frequency, if it's not in alphabet, which is just a list, I guess, we add it, and then oh, we only add the first letter, and then we add everything else, but we add the hashtag. So this is our vocab, basically. Alphabet. Nice. We also add a bunch of special tokens by the model. For bird, it is pad, unknown. This is supposed to be beginning of the word. This is supposed to be separator and mask. Cool. We also do that. Fun. Whoa. Whoa, 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 whoa. Why is it moving? Stop moving. Oh, that was pretty. Next, we need to split each word with all letters that are not prefixed by. I don't get it. Split each word with all the letters that are not the first prefixed by hash. What's happening? Brain stopped working. It's only been 40 minutes. Cool. Error. Fun. This is word frequency. Looking nice. And then we have our alphabet. Looking even nicer. We're adding our special tokens. And then the split says if. No, foresee if I is 0, else. I don't get it. I'm going to read it one more time. We need to split, but we already, oh, okay, now I get it. We need to have a word boundary thing, right? That is split. So yes, split will have the word and its corresponding split. So if we look at it, yeah, all right, I remember now. For example, shows, SHOWS. And it just does, for when I is 0, just put it back as it is. If not, add this hashtag. That's it. Yay, brain actually worked. And now we're ready for training. Let's write a function that computes the score of each pair. We'll need to use this at each step of the training. So the score, as we said at the beginning, is the frequency of the pair. We're looking at merge rules. And then the frequency of the first element, dot product of the first frequency of the first element and the second element of the pair. And that's the division. So we get rare stuff, not frequent stuff. It's basically the opposite of byte pair encoding. So we have letter frequency, pair frequency, because we need them for the equation. Oh, nice. Pre-roll ads disabled for another 40 minutes. Good. For the word and the frequency, which is the stuff we have in word frequency, we get the words split if the length of the split is small. We don't, hold up. If it's just one letter, letter frequency equals, so we just assign the letter frequency. All right. If it's just one, for I, from the beginning to the end of this split, which is a whole word, pair would be I plus what's in front of it, and then we get the frequency. Oh. Why are we, oh, this is only the first one. Okay, got it. So we assign the frequency, we assign the pair frequency? Shouldn't it be that? And then letter frequency. Okay, I'm lost with this last one, but I sort of understood some stuff. Brain only goes so far. Oh, I like this auto scroll. Stop. Okay. Auto scroll gives me anxiety because I'm supposed to finish reading things faster. So the score would be pair frequency divided by the frequency of the 0 part of the individual letter, and then the second part of the pair. And the pair frequency. I want to see what's in, well, we can't see what's in the pair frequency because it's method. But I guess we can see the score. All right. So if I want to see what's in pair frequency, what I'd have to do is take you out. Pair frequency gets computed right about there. Add you, put you back by 1, oh, by 2, all right. And then just splits, is that the thing that we are supposed to be getting? Equals, is it supposed to be, the whole thing? No, right? Is it the whole thing? Did I give it the whole thing? Yeah, splits. Splits is splits. That's it. So I don't even need to give you that. Do I just run this and something comes out? I'll run you. And then I'll look at pair oh, shoot. Nice. So we just calculate every frequency of every pair. I just don't get it how this frequency is the same here and the same here. That I don't really get. But frequency does not equal score, so it's sort of fine. That I don't get it, that part is fine. This is the score. Okay. Okay, let's look at the part of the dictionary after initial split. Oh, okay. We run this and what we get is TH has a really high score. And then we also get IS with a high score, which is nice. These are informative things. Finding the pair with the best score, we say, oh, I didn't really look at this code, which is just printing what's coming out of this. So the best pair, OTP, would be score and pair if max. Oh, we're just checking for max. Cool. Oh, well, AB. Where's AB? Oh, we're not looking at, it was not printed. Okay, so AB is the first. Oh, and then we have to do the merge. I'm not going to read the merge because it's supposed to be the same, like by pair encoding, and I don't remember what I learned in pair encoding, so I'm just going to slide by. The best pair, and then we add it to vocab, and then we're supposed to do the merge, and then you just add this here. Oh, about becomes AB OUT. Cool. Oh, and you have to declare what size of vocab you want, otherwise it could probably go on forever. I mean, there has to be a point where it stops, but it could go on as far as it wants. So, this is putting everything together, the score, the max, the merge, and I guess new token would be vocab, right? So our updated vocab has What other information is there? Oh, at the end. Okay. Because we don't remove what was already there. We have, ooh, full is something, fully. And then we have hug, chapped. And then we have, that's about it. Compared to BPE, this tokenizer learns parts of words as tokens faster. That does feel faster because it checks for uncommon things instead of extremely common stuff. Okay. I will not do that. What is this? Using train new from iterator on the same corpus won't result in the exact because does not implement word piece for training, but uses BPE. Okay, thanks. To tokenize a new text, we pre-tokenize it, split it, then apply tokenization algorithm on each word. Really? That is, we look for the biggest subword starting at the beginning of the first word and split it. Then we repeat the process on the second part and so on for the rest of that word and the following words. So, length of word, looping through length of word. Huh? While I is over 0 and is not in vocab, oh, it becomes unknown. And then we have this thing. If it's the 0th, and then this is supposed to be things that we have not seen. So like I give it something after it was trained, right? So we have hugging and then this thing, which becomes unknown. Let me try give it something that says like hello world. Would you encode that for us? Unknown. How rude. Okay. What about just hello? Still unknown? Oh, no. Okay, that's known. I guess it saw it as one thing. Cool. And then we'll write a function that does the tokenization. We have pre-tokenize, which is the split, and then we have result, and then each word, I guess, and then you pre-tokenize it. The course is an unknown word. What is this supposed to be? Before encode. This is text. Text equals. And then I want to see what is the result of, I guess, both steps. So we can just do a print, the result, which is supposed to be split. And then we can do a print of this. And then go. This one has offset, this one doesn't. That's it. All right, nice. We did it. Oof, I am tired. 1 hour? Almost 1 hour. So that was word piece. Did you have fun? Did you learn fun stuff? Oh my god, we have after Unigram, we have a building a tokenizer block by block in front of us. It's gonna be fun. I hope. I'm probably gonna do a half an hour of this thing here. If I refresh. Okay.
Cool. Any things about this?
Yes, all right. So yeah, I'm gonna play this.
Okay, I'm going to go next. So prompt engineering. When you're designing prompts, there's a number of different ways you can do this. You can do this manually. To do this, you configure a manual template based on the characteristics of the task using all of the knowledge that I told you before. You can also do automated search, and there's a number of different ways to do automated search for prompts. The first one is doing some sort of search in discrete space. So you find a prompt that is essentially text. The other one is search in continuous space. So you find a prompt that isn't actually comprehensible text, but nonetheless is a good prompt. So looking at manual engineering, making sure that the format matches that of a trained model, such as the chat format, is actually really, really important. And this can have a large effect on models. There's a really nice paper that demonstrated this convincingly before, and also releases some software that allows you to do this kind of in an efficient manner. And what this is showing is this is the original formatting of a prompt that was given, I believe, by some sort of like machine reading or document-based question answering data set, which was like passage answer. If you modify the spacing between the fields, that increases your score by several percentage points. If you remove the colons, that increases your score by a few more percentage points. It's kind of silly, but like little things like this actually can make a really big difference. If you modify the casing, this decreases by a lot. If you modify the casing and remove colons, so the thing that was useful, like adding colons here, remove colons, that further decreases. If you forget to add a space between the passage and the text, that really hurts your accuracy. So this is pretty painful, right? Like you don't want to be getting 0.036% accuracy when adding a space would give you like 75% accuracy, right? And one interesting thing is this is looking at different models. And
I need to comment and say how ridiculous this is. Just the spaces and the colons. Like sometimes you just figure out how everything is like hanging on by a thread. And this is just an example of that.
With different models, it's pretty consistent that many different plausible formats that you try, the average gives you a really low accuracy, but there's a few outliers that give you really good accuracy. And these probably correspond to the things that it was trained on, instruction tuned on, or other things like this. So number one, make sure you're using like the canonical prompt formatting for the model for sure. Number two, you might want to do a little bit of additional search to see if you can do even better than that. So this is something to be very aware of. Okay. Do you have a question? This is dependent on what it sees in training time. Another thing actually is this will definitely be tighter for like a ChatGPT or GPT-4 because it's been trained on many different formats at training time.
That's cool. Being trained on different things makes it stronger. I mean, I can't vouch for it, but like Whisper, as far as I've read or watched stuff on, says just because Whisper does multiple things, being ASR plus translation, it makes it a stronger model. So like, the more it does, the better it could be, which feels counterintuitive.
And so the better the model has been trained on a lot of different formats, the less this is going to have an effect. But you know, you're probably not going to be retraining a model that somebody gives you. So like this is something to be very aware of if you're just a downstream user of the model, especially in open source mode. Another thing is, how do you give instructions to models? Instructions should be clear, concise, and easy to understand. One very funny thing is, I think now, like actually prompting language models is very similar to prompting humans, especially if we're talking about like GPT-4. So if you're not very good at explaining things to humans, that might actually be bad.
I was like, prompting humans, does that mean asking questions or just like responding? Oh, by the way, don't know if that's a hack, but I haven't done it fully, but like, I was like, I use ChatGPT voice version far more, well, not far more, but like, I prefer using the voice version more than I prefer the text. And the other day, yesterday, I was like, I'm gonna read a paper. Can you help me go through it? And it was like, whatever. It was like, I might not have access to it, but I'll try. And I was like, do you know this paper? And I was like, yeah, I know this paper. So I didn't go through it because I was interrupted, but I'm gonna try doing that. Like each time I don't understand something, I'm like, explain it to me. And if I want a deeper understanding of it, I could. But I think I enjoy monitored or just like pair learning, group learning. So it makes me recreate that. Like as if there's a instructor next to you. I like that. So that's my cool tip for today. Is that how people use it? I don't think that's how, I think that's not how people, anyway, that's the tip for today, whatever.
And you might want to practice that. And explaining things to models might be a good way to practice that, right? So, it actually could give you feedback without annoying your friends by having you explain things to.
Yeah, even like I made this video. I did, about learning, practicing language with ChatGPT, because one thing is that you don't feel judged because it's not a human or just whatever AI model that's out there. It doesn't have to be ChatGPT. It could be Cloud Sonnet, which is, I haven't used it and I feel guilty. Does it have a voice version? If it does, then I should.
Them in several different ways and seeing how they react. So, but anyway, clear, concise, easy to understand is good. There's this prompting guide, which I can open. This has a prompt engineering guide. I like this site, but it does have a bit of like variance in the importance of the information it tells you, but like this particular page is nice, I feel. So start simple, start with simple instructions. You should tell the model what it should be doing. So make sure you say write, classify, summarize, translate, order, and things like this. It also gives some good examples of the level of specificity that you should be giving. So something that's less precise is explain the concept of prompt engineering, keep the explanation short, only a few sentences, and don't be too descriptive. Use 2 to 3 sentences to explain the concept of prompt.
Honestly, the other day, I tried giving it a long paragraph and asking it to make it shorter. I don't know why it couldn't for some reason. I don't know if my prompting was bad, but I've done that multiple times and it's done fine, but the other day it couldn't. I think my problem is that I was giving it multiple paragraphs and was telling it to make each of them smaller. I think my ask was too general.
Prompt engineering to a high school student. So what this does is this tells you the level of the reading level. So this doesn't even tell you the reading level, I guess. And then 2 to 3 sentences is more precise than keep it a few sentences, don't be too descriptive. So the more precise you can be, the better it is.
Most of the time I tell it how many words I wanted even, like 400 words or 300 words. But just the other day was not working and I was surprised.
Interesting thing is like, if you ask your friend to do something and they don't know how to do it, they'll complain to you. But right now, LMs don't complain to you. They may in the future. That might be like actually an.
That would be a fun feature. Another note. The other day I was talking with ChatGPT, and the amount of it said was literally like same number as I do. I was like, help me with writing this email, and every sentence it would read it would be like, I was like, oh my god, you're worse than me. It's cute, but it's off-putting just a bit. Like, don't overdo it.
An interesting thing to find, interesting methodological thing to look at for a project or something like that. But right now you need to be precise, and like it doesn't give you feedback when you're not being precise.
Hello. I was just drinking coffee, so hi, thirsty alien. HRU is supposed to be how are you, right? Oh my god, amazing people. Nice. Glad you're doing great. Hi, first time chatter. What's up? Why do you have two different icons? I see your icon on Restream one thing and on Twitch another. Cute. What is your opinion on prompt engineering? That's what I'm learning right now. Oh, Tony? Yeah, that's the only part I didn't read. Hi, Tony. Welcome. Welcome to our little corner of the internet.
So you need to know.
Is my voice back? Yes, it's back. Okay.
Separately from this, there are methods for automatic prompt engineering. So prompt paraphrasing, gradient-based discrete prompt search, prompt tuning, prefix tuning. So prompt paraphrasing.
What's automatic prompt? What was that? What was that? Automatic prompt engineering? My opinion on what? When you're talking to an AI model, like ChatGPT or the others, you're prompting it, you're asking for something. And to know what output, a good output to get, sometimes it doesn't understand you well. It's called prompt engineering. Like if you want to write some code and you ask it something, like for example, I say, I've actually done that a lot. Like, give me the step-by-step of this program, and it would just give you a step-by-step instead of giving you the actual code, which might have been what you needed. So you will need to be more precise and say, give me the code for this. And even if you don't explain the program well, it might not give you the code. So just prompt engineering would be talking to an AI model, chat-based or whatever, Yeah, chat. Yeah, makes sense. Chat can be voice or text. Yes, okay. Yeah, so this lecture is all about prompting. Isn't that fascinating?
So prompt paraphrasing, this is a method that we proposed a while ago to basically paraphrase an existing prompt to get other candidates. It's rather simple. Basically, you take a prompt, you put it through a paraphrasing model, and it will give you new prompts. And
there's a thing called a paraphrasing model. Sometimes I think we as humans do too much.
This is good because it will tend to give you things that are natural language. You can paraphrase 50 times, try all of them, see which one gives you the highest accuracy, and then use that one.
I don't know if this question is too little, too late, but how do we calculate accuracy of the output? A person checks it, is that it?
There's also an interesting paper that demonstrates that you can do this iteratively. So you paraphrase once, you filter down all the candidates that do well, and then you go in and paraphrase them again, and you just do this over and over again, and that can give you better results than kind of one-off paraphrasing. So that's very simple. You can even use a large language model to do the paraphrasing for you. Another thing that you can do is gradient-based search. So the way this works is you need to have a model that you can calculate gradients for. And what you do is you create a seed prompt, and then you calculate gradients into
sometimes in training you have to give it a seed, and I always am like what do I use? It's very, I don't know, makes you nervous. Okay. It's pretty neat to use some improvements. Nice. Yeah. Yes. And the lecturer, the professor is like, if you're bad at prompting an AI model, it means you're bad at talking to humans. And I'm like, harsh.
To that seed prompt. So you treat each of the tokens here, like T1, T2, T3, T4, T5, as their own embeddings. You do backprop into those embeddings and you optimize them to get high accuracy on your data set. Then after you're done optimizing them to get high accuracy on your data set, you clamp them onto the nearest neighbor embedding that you already have. So you basically
Original input, trigger tokens. What's a trigger token? And then we have a template. And then this becomes the output. A real joy, atmosphere, a lot, dialogue, clone, totally. What the hell is that supposed to mean?
say, okay,
You can look at the cosine distance of word to check the paragraph aligns with the short version. Huh. That's cool. Okay. Distance in paragraph space. Wow.
okay, the nearest neighbor to the embedding that I learned is atmosphere, then a lot, dialogue, clone, totally. And
yes.
So this will actually give you better results than paraphrasing in many cases because the search space is less.
Oh yeah, there was a question mark at the end. Can you? It was not you can. Why not? The answer is I don't know, so why not? I could probably ask something, but I'm not gonna. Like, you know, I'm being lazy right now.
Constrained. You can get these very unnatural prompts that don't seem to make sense, but actually work well. This has particularly been widely used in adversarial attacks on language models. So how can you come up with
adversarial attacks on language models? Meaning making it output something it shouldn't?
With prompts that cause language models to do things that you don't want them to be doing. And there's actually this nice paper also by.
We had sometimes, yeah, there were times that people, besides asking it, that my grandma used to tell me stories of Windows code. Wait, what was it? The thing, activation key. There were some stuff that people would coerce it into, like, you know, asking it way too many times, I guess. I don't know, but yeah, even the stealing and the making of the bomb, all of that stuff.
By people at CMU called universal and transferable adversarial attacks on line language models. And basically what they do is they try to optimize the prompt to create a prompt that causes the model to do bad things, basically. And they try to do it even on models that have been trained to not do bad things. And they demonstrate that, number one, you can cause things like models like Llama to do bad things, like output toxic things, tell you how to build bombs, stuff like that.
Yes. I was like, what is supposed to be bad things? But yeah, these stuff.
That. But also the same prompts also work on like GPT models, which is kind of like interesting and very, confusing in a way, because you thought this might be exploiting idiosyncrasies of a particular language model, but actually it's not. So I find this kind of fascinating. So if you take that a step further, one thing that you can do is you can say, oh, actually, there's no reason why we need to clamp these embeddings back to an existing embedding, right? So we could just optimize the prompts, the embeddings of the prompts that go.
Are we thinking too much into this? Let me just ask good stuff and be done with it. Sorry. Prompt tuning. Optimize the embedding of a prompt instead of word. Do you need to have embeddings of prompts?
For a task and not clamp them back to embeddings and just
Hello. Freedom Thou? Thank you for capitalizing for me, Coffee. Good vibes are being sent right back to you. Hi.
just keep them as is. So what I mean by that is like right here, it's optimizing T1, T2, T3, T4, T5, and then clamping that back to atmosphere, a lot, dialog, clone, totally. But just keep them as is and don't worry about them like actually being a token in the model. Because if you have control over your model, you can just add them as new elements in the vocabulary and you're fine, right? So what they demonstrate in this paper is that instead of taking your 11 billion parameter model and training the whole 11 billion parameter model for many different tasks on many different data sets, they just train these prompts, which are like 20K parameters each. I forget how long it is. It's like 10 tokens or 20 tokens or something like that. And train it on all of the data sets here.
I also think that prompt tuning is like I get it. Humans want to test everything. Thank you. We probably wouldn't have I don't know, marshmallows without it, but yeah. Mixed task batch. Instead of having it on each one, which is 11 billion, mix them and give it to it. Trail mix of prompts.
And you don't actually need to do multitask learning. You don't need to train on multiple tasks at the same time. You can just train on a single task.
Because the model is already big and it could, what's the word? I don't know, forgot it. Hamul is the word in English. Okay. Oh, sorry, Arabic. God, what's wrong with me?
So,
the main reason for me to do the prompt tuning is reduce the input tokens count. So you would do it? I wouldn't. I'm just learning about it, but I wouldn't. I guess. No, I'm not at the level of being able to do this at all. No. And yeah. Oh, it's old age. Ah. Oh no, I am. Yeah, I mean, yeah, I'm old. Okay. Let me search my brain for the word tahammul. Something that endure. Something that you can. Okay, but I don't think the word endure would work here. Just like it accounts for them. It can. Have you used OpenAI endpoint? Nope. It's just if you have time, try prompt tuning. Maybe OpenAI Playground. I haven't tried any of those stuff. Is there a thing called an OpenAI endpoint? Okay, so it's a API. I'm just looking at this. Cool. Endpoints. Ooh, audio, and then chat. Fine tuning. What can be fine tuned? Shut up. I don't believe you. I mean, I've literally never been here, so seems like fun. I don't trust OpenAI enough. Okay, I like their stuff a lot, but I will see if I can look into it. I use their API for most of my programs. Cheap, huh? Released mini meant. Oh yeah, mini is supposed to be, yeah. I get nice results. Yeah, Pro is quite powerful. Yeah, I saw the news about the mini one, and I was thinking, would it be useful for edge computing because it's mini? 15 cents per million input tokens. Wow. Oh, input and output, different cost. Okay. Another one that Open Models LM-SIS from Berkeley. Free research to compare models. They have direct chat with Llama 3. I have worked with, what is the Olama version of Llama? Whoa, what is this website? Come here. Come here. What is happening? Too much information. Okay. Might have been Llama 2. Got it. Chatbot Arena. Is it fight to the death? What's happening? Oh, Gradio. Huh? Okay. Oh. Wait, where have I seen this before? I feel like I've seen this before. Ask any question to the 2 anonymous ones. And then we have image direct chat, which would be, I don't see it. Is it somewhere around here? Compare models or direct chat? Oh, there it is. Found it. Sorry. Oh, hi. That's Claude. You can just use these? Like that? Whoa. Wow. I don't have anything to prompt. I'm gonna send this to someone that would find this interesting. Yeah, I know. That was hella useful. Thank you so much. Oh, okay, sure. I'm gonna try that. Tell me. All right. Let's do that. Do I just ask one of them? I'm copying your text, by the way. Paste and go. Knowledge about fine-tuning and provide you information. Thank you. I have a hard time reading long text. Okay, this is not as long as ChatGPT. Like ChatGPT sometimes gives way too much text. Oh, thank you. I don't know if you have seen. Wait, have you been here before? Oh my God, what's wrong with me? You were not a first-time chatter. Oh, no, you were not. I'm sorry. Thank you. I'm glad that you enjoyed the streams. I sometimes don't know what I'm. Okay. Sometimes I don't know what I'm doing, but I'm glad that someone enjoys learning with me. Method used to optimize performance without the need of the fine-tuning of the entire model. Introduced as a more efficient alternative to traditional. I'm a traditionalist on this one. Aren't all private, right? Like it can be used as chatbot arena data. Oh, fair. I mean, that goes for almost everything. Okay, they use it in their research. Fair. Okay, so efficiency, flexibility requires fewer trainable parameters. Fair. Applied to various tasks. Now I'm thinking, how can this be applied to audio? Prompt tuning can achieve comparable or even better results. That's a lie. I mean, I don't know. I'm just saying. More public than ChatGPT maybe pretends to be. I mean, this is public facing, so it just feels public. Prevention of general. Not modifying the base, fine-tune helps maintain general knowledge. Can be used with different types of language models and architectures. Fun. That's fun. Just important to keep in mind. Yeah. More powerful than GPT 4.0 on many things, but it's completely public. Aw, you're kidding. I mean, thing about Llama is that you can put it on your server with Olama, so then you're good, right? Please tell me that's the case. I want to use the arena for once, and then I'll be done with it. Okay, so that's supposed to tell me it's Y is no. Okay, let's go with what's a rainbow. How's that? Or what's the closest star? I mean, the answer is probably obvious. Alpha Centauri, right? So, someone tell me that Model B is ChatGPT. Because it always, Proxima Centauri, shoot, always gives out way too much information. That, Alpha Centauri, A and B? Haha, sun is closer. That's funny. With the most advanced, we may be able to know certain things or even have a copy of things done in the past. Problem with obtaining this kind of data, you have to deal with simulation AI. It's quite a complex thing where we cannot get 100% accurate data. I mean, the whole thing about internet all being AI is also something. Sun is closest star to you. Okay, I might be on some. Wait, how do I know which one is which? It's not going to tell me? I prefer A, obviously. Closest star. Holy. Did you see that? Your model A. The sun. I didn't say compared to what. Okay, fair. Many stars. Closest star to Proxima Centauri. It is in the Alpha Centauri star system. Got it. I'm gonna make it a tie. I'm not gonna judge. Oh wow, Llama 3 and Gemma. Oh no, I did rank them and I thought it was a tie because they gave out different information that both are true. This is fun. But this one felt like GPT. Main model being used here. The instruct one. That's why it's being so teach. Because it's instruct. Got it. Sounds like a teacher. Start over. Regenerate. New round would be different question, right? Or different models. Different questions. No, I'm not gonna do that. Oh. Unigram versus BPE? Sure. I'm gonna go unigram versus WordPiece versus BPE. Three things. Versus word. Wait, how is the thing WordPiece is written? You go here. Here. PIEC. Instruct, you can have it right short, and if yeah. That's true. That's true. That's one way I do that quite a bit, telling it to give me a summarized answer. Because I don't, if it's talking to me with audio, I don't mind it being a long answer, but if I have to read it, like this now, my eye is just glazing over. I will never read this. Oh, I like this. I like this. Summary of difference. I mean, that should be, no. Oh my God, I like this more. Even though it's way too long. Okay, we have unigram. See, this is shorter. Granularity. Okay, we have advantages and disadvantages and use case. Here we have definition, characteristics, pros and cons. And then at the end we have a overall summary. Subword, yes. Oh, what's OOV? High, because it's each is a word, yes. Merges and likelihood. Complexity. Word piece is the highest. Contextual, general, simple. As much as I like a good short answer, this one is better. It's hurting me. Out of vocabulary. Got it. Okay, fair. Yeah, a word that it has not seen. Yep. I'm gonna choose A, even though I think it's like a 51 to 49. GPT-4, A. That's cool. Oh, it's mini. It's mini. Oh my God. Last update like a few days ago. And DeepSeek. DeepSeek, you're doing a great job. Don't even know who you are. Yeah, we got to test the mini. Well, that was fun. Oh, it should be in this list, right? In the direct chat thing? Yeah, it's in the list. I'm gonna go back to my video, but I really enjoyed this. Thank you for sharing it. I'm gonna share it with someone. Oh, actually, I could probably share it in on Discord. I don't know if you have it. If you do, you can put it there. If not, I will do that later. I'll go back here.
Now let's take that even a step further. So this is only training the embeddings that you input into the model. There's a method called prefix tuning. And the way prefix tuning works is instead of training only the embeddings that go into the model, they actually train a prefix that you then append to every layer of the model. So prompt tuning basically does this for the first layer of the model. Prefix tuning does this for every layer of the model, and you append a prefix for every layer. So it's just a more expressive version of prompt tuning.
I know there's a video on YouTube that's really useful about setting up Olama on your server, and there's a part where the guy is preparing the model for his kids to use as a helper teacher. Oh, hi, what happened? He gives it some sort of instruction in one of the settings where it says do not provide full answers, only how, like guide the person. And would that be prefix tuning? Not really, right? Because you're not giving anything back to the model, but you give it as a prompt always.
Essentially. So these are all kinds of gradual steps from a human created prompt into something that is basically training a prompt or a prefix to the model. So I would take questions, but let me get to the end of this section also, because I think there's interesting analogies here. So in the next class, I'm going to talk about parameter efficient fine-tuning methods, which is kind of a more general, it's a more general version of prompt tuning or prefix tuning. There are methods that tune a small number of parameters to get the model to do something. And there's a bunch of different parameter efficient tuning methods. Many people may have heard of something like LoRa or adapters. I just talked about prefix
I've heard LoRa way too many times and I still don't know what it is, and I'm too afraid to look up.
tuning. So essentially, prompt tuning and prefix tuning are part of this more general class of parameter efficient fine-tuning methods. And so what we can say is actually prompting is fine-tuning. Prompting is a way of fine-tuning the model or getting the model to perform a particular task. And we have this taxonomy of, we have prompts in natural language.
Okay, but nothing goes back to the model, right? The model does not learn anything with prompts unless there's a way to give it back. Oh, there's Dora. I thought that, because I sometimes do the, what did we learn today thing, and I thought you were just referring to that Laura and Dora. So we start doing the Sesame Street of, is Dora Nickelodeon? I think Dora is Nickelodeon. Dora's friend Diego. We should have Diego as well.
That are created by humans. Actually, maybe I should say manual prompt engineering here. This was first done in the GPT-2 paper, where they demonstrate that models could solve tasks by doing it this way. Prompt paraphrasing is a step up from this because it's no longer relying on human engineering, and you can...
Low rank adapter, method to fine-tune a large model by tuning a subset of the model weights. I don't understand what it is, but thank you. Like, cool. Modifying the weights, subset of the weights, and then testing it, and then trying for a bit more, maybe. That's what I would do. Cool. Low rank adapters. Good name.
Expand to a broader set of prompts. It can always start with human created prompts, so it's kind of like broader than that. Discrete prompt search doesn't necessarily need to rely on a paraphrasing model. It could rely on like gradient-based models or something else like that to give you something that's not actually natural language, kind of just random tokens. Continuous prompts or prompt tuning is a step above that. Multi-layer continuous prompts or prefix tuning is a layer above that. Parameter efficient tuning is more general than that. And then you have all training methods, so including fine-tuning your model. And so what are the implications of this? I think, so a lot of people when prompting came out, they were like, prompting methods are very hacky. I don't like how we have to do manual prompt engineering. It seems like a dark art as opposed to like, actually, some sort of well understood.
Dark art? Where's Severus Snape? What's happening?
Fine-tuning method that we could use. But I actually like them. I like prompting a lot because if anybody is familiar with like Bayesian statistics or machine learning, we have the concept of like a prior probability over parameters, and then a probability that we get after fine-tuning the model or after training the model. And prompts, in a way, are our first like good prior over neural network models. They give us the ability to specify what task the model should be doing, or like a general idea of what task the model should be doing before we ask the model to actually do the task. And so we can either use that prior as is, we can use a prompted model as is without doing any additional tuning, or we could take the prior that we have given to the model by using a natural language description of the task it should be doing, and then combine it with fine tuning. So we can take the prompted model, we can initialize the distribution of this like task A prompt using a human created prompt, and then go ahead and fine tune it on lots of training data as well. And there's a method for doing that by Schick and Schutz called pattern exploiting training, where they do exactly that. They basically initialize with a manually created prompt, and then they fine tune the model on fine tuning later after that. So that's the reason why I like prompting-based methods. They give us this like really nice way to very quickly create a system, but we can also have, you know, whatever level of additional training on top of that.
Cool.
Cool. So that's a little bit early.
Nice. Ooh, fine tuning. Actual fine tuning or for funsies fine tuning. We have a whole lot of stuff to go through. Let's go here. We were just here prompting, and then we're coming on to fine tuning and instruction tuning, which feels like prompting, but we'll see. I like fine tuning. We'll see. Pruning. When was the last 2 months ago? Okay. Ooh, fun. Nice. I like it. This will take us a while, so just let's go through it. Chill. We'll probably finish this before we finish this one, but yeah. Oh, if I go back to the HuggingFace learning thing, where is it? Right here. We have other stuff to go to, so that's fun. I will most likely go from here to here. This feels the most natural. But that will also take us a while, and that's all right. Cool. What a fun learning thing we did. Okay, let's do a quick recap. We learned about word piece tokenization, and then this is a really quick recap. We learned about prompt engineering. Yeah, I think that was what it was. And then we also learned about the chat arena, and it made me think of the scene in Dune in the arena. So yes, that was it for today. An hour and 45 minutes of streaming. I am proud of myself. Pat on the back. The other day, actually, I said I would come back tomorrow, but I didn't, and I had a really good reason, which was I was not anywhere close to this setup. But I don't have a reason for tomorrow. So no promises. We'll see how it goes. Okay. Thank you for being here, and thank you for your fun commentary sometimes. Thank you. Yes. Today is Monday, right? I wish you a lovely Monday. I watched the Garfield movie very recently, and the thing that bothered me was that the first thing he ate was a pizza. Like, that just felt, I don't know, not right. And then there were lasagna. Anyway, yeah, I wish you a lovely Monday, and inshallah things go well. Yeah, both sides. Nice day all around. And I'll report back next time for learning new stuff. So, might be Saturday night in the US, I think. Sunday night. Maza. Right. You are right. Then I wish you a lovely rest of the night and also a nice morning, which would be Monday. Okay. Yes. Thank you. Yeah. All right. I'm about to end the stream, starting from the countdown of 5. Let me know if there's anything else. Otherwise, Thank you for being here. I hope we learn fun stuff together, and by any chance you can't join me live, I really don't mind. Just, do what's good for you. So yeah, gonna end the stream in 5, 4, 3, 2, and 1.